So welcome everyone.
Evening.
Do you want to go back to the beginning of your presentation, Akmal? I'll just make a few brief remarks. Very pleased to see so many people here, and I believe there's still a few more coming. But we've got a lot to cover this evening, so we're going to start in just a minute. As you may know, this session is being recorded to the cloud. So if you don't want to be seen, then turn off your camera. If you don't want to be heard, then turn off your microphone. In any case, I'm going to mute everyone as soon as Akmal starts his talk. I just want to draw your attention to the upcoming program. We've got sessions at the first Wednesday of each month for the rest of this year. Gosh, that's going back a long way, isn't it? what you're just looking at here, Akmal. Yes, this program's been going for a long time now. And in May, our former chairman, Nader Talay, is coming back to talk to us about being agile in a business context. You know, the Agile Survival Guide, and he's a strong advocate of the Scaled Agile framework. I'm going to be very interested to see how that goes, because there are quite a few skeptics, me amongst them. And then for June, I'm still looking for someone. For July, Kevin Henney is going to come and talk to us about something probably architecture related. For tonight, I'm very grateful that Akmal, who's presented to this august body many times, has decided to take us through data analysis using Pandas. So I don't believe you work for Infomix Labs anymore.
No, Imo.
Introduce yourself briefly.
No, that's right. So just bear with me whilst I make sure that my desktop is okay and video and mic is working, looks good. So I just hide these floating meeting controls. So thank you very much to yourself and again, the BCS SPA group for inviting me along. And as you can see, hopefully you're able to see this Chrome tab here, which is actually, you know, I was kind of curious because I know I've done some presentations in the past, and I was wondering what was the oldest presentation I'd done for this group and its predecessor, which used to be called the OOPS specialist group. And so this was the one the earliest one I could find with any evidence, but I think there was an even earlier one that I did. So this one is from way back when. It's July 2001, and I used to work for Infomix at that time. So you can see the link here, and this is bcs-nespa.org/previous-meetings.html. So that was OOPS 153. And I was curious whether any of those links actually work. Well, the link to the meeting page, this one doesn't work. The link to the shockwaves doesn't work. Shock machine player, that doesn't work. But this download link here to the slide deck and the little video from Babylon 5, as well as a white paper on object-oriented databases does work. So that link is something that's actually got my old slide deck. And I was browsing through it a little bit earlier today, just before we started, and it's kind of brings back fond memories. And at that time, I think, you invited me to this to do that talk. So it's been 20 years. So it's just reminiscing. Anyway, that's life. World moves on, and things change. So Infomix got acquired by IBM, and then I ended up at IBM for quite a long time. Anyway, let me close this tab, okay? Let's get rid of this. All right then, so first thing everyone needs to do is please check that you have registered for the community edition for Databricks. This is going to be a code along, okay? So it's not me just doing stuff and you watching. You're going to code and run stuff as I do it as well. We'll do it together. And so
put into the chat one more time the link to sign up for Databricks, just in case somebody hasn't done it.
Yes. So if I do it here, okay, let me Databricks CE. Okay, right. So this is Databricks Community Edition login. Now I suspect it's going to go straight to here because I'm already logged in. So actually, let me just do this part for you. Okay. And if you go to this page, pardon me. Okay, so let me pull up the chat. And so let me post this in here. So if you go to this page here, which I'm just going to post the hyperlink into the chat, what you'll see is that there is a link there. It says, it words to the effect that if you don't have an account, click this, okay, linked to that. And so you just register. The key thing to note here is that you'll get to this page that asks you for some details of yourself, your name, email address, and so on. And then you just click register. And then on the next page that you get after you register, you have like two choices. One is like trial edition. You don't want that. The other one is the free community edition. You do want that. That's the one you want, okay? And so when you've got that, right. So Raymond, unfortunately, no. So essentially, the notebook that we're going to use, it does need a cluster to execute. However, if you would like, let me see what I can do for you. If you just want to kind of follow along but not run the stuff, you're welcome to do that, and I can give you a way that we can do that. So bear with me one moment and let me figure out a solution for that. So if I go here and I go here, let's have a look. Now, did I run the cells in this case? I did. So one thing I can do, I can simply export this out as HTML, which I've now done. Okay, and the HTML, bear with me. Okay, whilst I just take a look at that and just make sure that I've got this here. So the reason for exporting it out is HTML, so that if you don't want a cluster, but you just want to kind of follow along and see what I'm doing, because it's an HTML file, you double click on it, it'll just open in your browser. As simple as that. Okay, that will be something. If you're not inclined to create an account at all, you don't want a community account at all, but you just want to follow along, you can do that. All right, so I'm just going to put that into the, there we go. So that's just uploading now. Okay, so if you look inside the Zoom chat, you'll see the first thing I posted this evening at about 6:27. It's a file called data analysis with pandas.dbc. What is DBC? It's a kind of a compression format, tar, zip. Okay, and it's readable by the Databricks environment. And then just now at 6:38, I posted exactly the same file, but with the .html extension. So if you want to save one, both, either, whatever your choice is, you're welcome to do so. The HTML, you just double click on it and it will render in a browser for you. So if you don't want to create a CE account, but you just want to look to see how we're going to do this, that's absolutely fine. And interestingly, actually, either file can be imported into the community edition. It's perfectly happy with DBC. It's perfectly happy with HTML. Either format is okay. So that will work. All right, so there we go. Okay, so hopefully you've all managed to sign up, and you've got, when you log in, you'll see a page that looks like this. Welcome to Databricks. Okay, and essentially, if you look, this is your workspace environment. That is what you get by default. Now, the thing is, because it's community edition, let me just close a couple of these things here. It's rather limited in capabilities, but that's by design, okay? So it's not meant to be used for any kind of enterprise type work, but it's fine for demos, small scale demos. If you want to, teach yourself a little bit more about Databricks, Spark, related technologies, then that's absolutely fine. Okay, so it is perfectly okay for small scale. And the notebook we're going to use this evening will work absolutely fine in this environment. Now, once you've logged in, you'll see that you have a left nav. Okay, over this side, there we go. And it's got a bunch of icons there, as you can see. So let me just highlight these. So you've got home, workspace, recents, data, clusters, jobs, search. So the first thing you want to do is to import the file, the DBC or the HTML, either is fine. It'll happily work with those. And actually, there's a couple of other formats it will accept as well, but either of those is fine. You can just click on the home icon, like so, and you get this kind of navigation pane that pops up. And what you'll see is that at the top here, I mean, obviously, I've got a bunch of stuff in here. You can see some directories and files here. But at the very top, you've got your login credentials there, the user ID that you're using. So mine is, as you can see, it's not a Databricks email address, it's just a live.com email address. And so that's the kind of like the root folder, if you like, or the root of the directory. And at the end of it, you can see there's this kind of arrow. Okay, so if you just click on that, you'll get a couple of options. Create, clone, import, export, copy link address. So you want to select import, and you'll get an import wizard that now gives you two options. Okay, either a file or a URL. We're going to use file. So please save that DBC file or the HTML file in the Zoom chat to your local drive. And once you've done that, all you need to do here, either drag it to this part of the wizard, or just click on the browse to locate it, like so. Okay, and when you do that, then it gives you the opportunity to find that. Now, in my case, you can see it's already pointing to my downloads folder, and I can see here that these two, I've got the DBC and I've got the HTML. They are there. So either of them would be fine. I can select them. I'll do the HTML like so. Okay. And then you'll see just here down at the bottom, you can see there's a button to open. Just select this like so, and it will import that in, and you'll get a tick mark, green colored in the corner here when it's successful. You can see it's 0.9 megabytes, just under a meg in size. And once that's done, again, just click down below here. You'll see the import button is active now. Previously, it's kind of ghosted out until it's actually got something to import. And then if you just select that, what it will do is just read that file into the environment. And there we are. And it opens it up for us. Okay. So if I just go back to my workspace now, because I think I already have that file, I've got it stored in a subdirectory, but that's fine. I can use this one. That's not a big problem. And actually, this HTML, because I've previously run it, you will see that there is output there as well. So these code cells have been executed. So for those of you who want to just kind of follow along and you don't want CE, at least you can see what the output looks like, which is great. For the rest of us, unfortunately, that doesn't help us because then we've got nothing to do. So what we have to do is to kind of clear the output and then rerun these cells and then kind of start at the beginning and work our way through. So that's what we're trying to do. Now, I notice there's a couple of things in the Zoom chat. So let me just try and see what's happening here. All right, so the file is in the DBC. Sorry, in the Zoom chat. It's a DBC file. Emo's posted it as well. I've posted it too. And okay, and okay, so it looks like it's possibly some people haven't joined, so let me do that again. Okay, So we can do that again. All right, there we go. So it's just uploaded that now, and I can give you the other format as well. Again, HTML. There we are. Okay, there we are. So now you've got both the DBC and the HTML posted at 6:45. Both of them at 6:45. Okay, so everyone should have those now. There we go. Okay, so hopefully you're all at this point now where you have managed to import this file, either the DBC file or the HTML. Either is fine. It will happily work with either of them. And so what we need to do, the next thing we need to do is we need to create a cluster, because we need some resources to actually run the code in this notebook. And so again, if you look on the left nav, one of the options that you have there, it says clusters. So if you just click on that, and I have a tab open already here, and this is, as you can see, I've already got something configured here, but you should see something like this, okay? And if you look at the top there, there is an option, and there's a big blue button that says create cluster. Okay, so just click on that. Now, because I already have a cluster running and created, because C is a little bit limited, it won't let me create another one. So I'd have to shut this down, delete it, and then recreate that. I kind of don't want to do that. So it takes a couple of minutes to go through that process. But essentially, if you just click on create cluster, okay, you get this box. Very straightforward, not much to configure here, and that is part of the CE environment. Essentially, with the paid version of this, if you actually decide that you want to do some enterprise development, you get tons of options on this page in terms of what you can do. But the least thing you need to do here is just give the cluster a name. So the cursor should be flashing inside the box marked cluster name. That's all it's looking for as a minimum. Okay, so just give your cluster a name, call it anything you want. Okay, I've just called my initials and surname. You can leave the Databricks runtime version as is. Okay, so that's the next box below it. And you'll see at the bottom, it's got a couple of availability zones there. So if you decide to look on that, you'll see it's US West 2C, US West 2B, US West 2A. I think leave the default, or you're welcome to select any one of those. It should be fine. Okay. Now, once you've done that, just give your cluster a name. This box at the top here, create cluster, will become active. Now, because I already have one running and it only lets me create one cluster at a time, I can't create another one. So your case should be different. That button should be active, should be blue, and just click on create cluster, and it will then provision that cluster for you. Now, surprisingly or amazingly, the cluster is just one machine. All right, that's again a limitation of the environment. And so at the top, you'll see what you are actually getting here. You're getting what's called a driver. How much memory? It's 15.3 gigabytes of memory. It's got 2 cores. We don't get any workers with this. So seriously, if you want to do enterprise work, you would need, have something somewhat more substantial than this to do serious work. Okay, you'd get a driver, and then you can create some workers as well. That's the key thing here. Okay, so just click on the create cluster, and then what you'll see is, again, if I go back to my cluster page, you'll get this kind of this is solid green here. Okay, so that means my cluster is active, ready for work. In the case that it's provisioning in it and it's just getting there, it'll be like a kind of rotating beach ball type thing. You'll see that. And after a couple of minutes, it will become a solid green. So then it's ready to work. Okay, so as I said, just leave the Databricks runtime version as is. That's fine. If you like, change the availability zone. It's entirely up to you, or take the default. But really the only thing you need to do is just give it a name. And by default, this will run for 2 hours if left unattended. Otherwise, if you're using it continuously, then that's okay. It won't shut down. But essentially, if you stop working with it and you don't do anything on the cluster, it's idle, it'll just shut down automatically after 2 hours. It just tells you at the bottom here that that's going to happen. Okay, so that's fine. Okay, so you have this workspace environment that you've been given as you log into the Community Edition account. You should be able to create a cluster, quite straightforward. Just give it a name, and you've imported the notebook that we're going to work through, and you've got everything now. All 3 things you have available to you. All right, there's some comments in the Zoom chat. Let's have a look. Yeah, Steve, yes, they are indeed AWS zones, yes. So this Community Edition is being hosted on, Microsoft, Amazon Web Services. So this is where it is being hosted. Indeed, that's correct. Databricks itself, enterprise level stuff is available on the 3 major cloud providers in the Western world, AWS, Azure Databricks, as it's called, on Microsoft Azure, and GCP as well. And if you happen to work with customers out in the Far East, then Alibaba, I think, is the other cloud that's available on out there. Okay. Okay, so hopefully that's good. Sorry about that. It's taken us 20 minutes just to get that far. So it's a one-time operation, okay? The setup is always the tricky bit, because if you're not familiar with it, I understand. You know, you need a couple of things to get right, but hopefully it's not been too difficult for you. You've managed to import your notebook. You've got your cluster up and running. And then the next thing to do is basically, you can just go to your home if you like, locate that file if it's not already open, okay, and just click on it and it will just open it up for you like so. Now, at this point in time, the notebook is, and if you've worked with things like Jupyter notebooks, for example, this is much the same thing. It's not actually attached to any resources, so we can't run any code in this. So the first thing we need to do is to attach this to that cluster that we've created. Now, your cluster might still be provisioning. That's okay. So what you need to do, in the top, you'll see a box there, and currently it should say detached. All you need to do is a pull down, and you find your cluster and you just attach it. Now, because my cluster is up and running, already got a solid green, now I'm ready. I can start executing the code cells inside this notebook. If yours is still showing that kind of beach ball thing, don't worry. That should go away fairly soon, and your cluster should be up and running. And there we are. So now what we can do is, because, as I said before, I've run this. So for those of you that don't want to go through all this pain of setting up C and everything, you're welcome to look at the output that we've got. But for the rest of us, there's no fun then. So we need to clear all of that output. And the way to do it, and again, because my Google Chrome, I've got kind of limited real estate on my desktop. I've got icons showing. You may have text as well. But this very last one here, okay, if you take a look at that, and then just pull down, there is an option there that says clear state and results. Okay, the third one down from the top. If you just click on that, and it'll just helpfully ask you, are you really sure you want to do this? Do you want to delete all the output? And I'll say yes, confirm. So that clears everything out for us. And now we're ready to start running the cells. Okay, so essentially then what we're going to do, we're going to do a little bit of data analysis, and we're going to use this thing called Pandas. Right, so this is a code along. Remember, it's not me just showing you stuff unless you've decided not to create CE account, but you're going to run this code along with me, and you'll be able to see the interactive results of doing so. So essentially, we'll cover a little bit about some of the commands that we have available to us. So we can read some data in, and then we can do a little bit of manipulation of that data. We can look at some statistics. Okay, we'll look at that. And we can do a bit of slicing and dicing as well. We'll look at that. Some filtering, and we run a couple of other operations as well, and how to treat things like nulls and missing data as well that we might have in a data set. And then we'll do a little bit of visualization as well, histogram and a scatter plot as well. And you'll see how this is all done. Now, the key thing here is that each of these cells has a number. A little bit hard to see sometimes, but right at the top, you'll see here, this one is called command 1. So I may reference a particular cell. I may say command 6, command 7, then you know exactly where I am. So this is command 1. And at the bottom of command 1, you see there's a couple of links. There's a cheat sheet that's referenced. Okay, so let me just highlight this, as well as the Panda docs themselves. So if you load and you open up that cheat sheet, it will look like this. Okay, this is a PDF file, very useful. Keep that handy if you're ever working with this. Gives you lots of these things at your fingertips so that you can see how to manipulate data. As far as the Pandas documentation is concerned, well, this is the website, pandas.pydata.org/docs. So that will take you here. And again, getting started, user guide, developer guide, API reference, all of this stuff, well documented. Just bookmark this. And that's essentially it. And this is Markdown, by the way. So this cell here, this command 1, if I double click inside it, there I see the Markdown code. And if you want, you're welcome to add your own comments in there. And either hit the escape key or just click your cursor outside of the box. And I'll do that now, and it will just restore that like so. Okay, so I've added nothing here, and that's fine. Okay, so a little bit further, let's move down to command 2 then. So what's this whole thing about pandas? Well, the thing is, key points here. Humans are tool-using animals. Computers are one of the most powerful tools we've created. And if you write code, you can unlock the full power of these tools. So in a nutshell, essentially, we're able to utilize this simple cluster of one machine. Yeah, I mean, it's not very, it's not going to be great for any kind of enterprise work, but certainly for this small problem that we're going to look at, which is going to be kind of COVID data again. Okay, so if you attended the session I did about 2 weeks ago, it was a different COVID data set. Now we're going to try another one. And we're going to use this technology to help us do a little bit of analysis of that. And why pandas? You know, why this specific technology? Well, if you think about it, I mean, in theory, you could use lots of other tools as well. Even things like spreadsheets. You know, Microsoft Excel, you may be a big user of that already. There are some benefits to that. Perhaps you may be able to create some automation, some macros, some other things like that. But in the main, the job of a data scientist, you know, often it's about discovery. You're trying different things out, and you can do the visualizations. And so using something like Pandas gives you a lot of power at your fingertips. There's a lot of great things that you can do, and it doesn't require a lot of time to figure out how to use these. The cheat sheet, as I said, is a great place to start, and you can do a lot of this analysis quickly, take a look at the data, get some idea of what's going on there, and then decide to dig down deeper. And so that's the key point here. So by all means, there are plenty of tools out there that you could use. So the goal here is not to say that those aren't useful. Of course they are, but we are deciding on using this particular one at this particular time, just because it happens to be convenient for us. Command 4 here talks a little bit about pandas and its history. I won't go into the detail there, but essentially, again, you can spend a little bit of time researching this. Built in 2008, open sourced in 2009, very popular technology. And there is a book. So the book here, I'll just click on the page for Amazon, and this one, Python for Data Analysis. Okay, Wes McKinney, the author. So as you can see, it's almost a 5-star rating there, 961 rating. So paperback version and Kindle edition as well. So, I mean, by all means, you can Google, you know, there's plenty of great material out there, but if you want to go to the source, if you like, or you know, find a good publication to look at, I think that's the one that seems to be the most highly recommended one to get.
What a shame that there isn't a picture of a panda on the cover.
Yes, I think that's typical. It's an O'Reilly book, isn't it? So they decide to choose whatever they want, different animals for that purpose. All right, then. So now, Command 5, import the COVID-19 data set. So what we're going to do here is, let's have a look. Let me clear state and results. I thought I'd done this already. Yeah, some reason, maybe I'm looking at the wrong view. Okay, anyway, doesn't matter. Let's take a look. Make sure I'm pointing to the right one. My apologies. I've got a couple of windows open here and I was indeed looking at the wrong one. That's okay, no worries. There we go. Okay, so if you take a look at Command 7 here, we've actually got a little bit of code there. So the nice thing about the notebooks is the ability to put some markdown in. You can have cells that contain graphics, tables, images, and you have these code cells as well, which you can actually execute and get some result back. So this one here in Command 7, what is this doing? Well, Databricks provides this public kind of location. It's called Databricks-datasets, which you can access through CE. You can access if you're on Azure or GCP, on AWS as well, if you're paying, you know, in terms of enterprise support. And so here is a specific subdirectory with some COVID data sets that we can look at. And so just execute this. Okay, so I'm just going to do shift return on my Mac here. And now this code is being executed on our cluster of one machine. And there we go. It produces some output for us. Okay, so %fs is just a file system command. ls, if you're familiar with Unix, Linux, those type of commands, ls, you know, is just a directory listing. And we're just asking it to show us at the high level. This is not recursive. Okay, so just show us at the high level, what is the contents of that directory? What are the contents of that directory, this COVID directory? So you can see in there, it shows us that there are some files. And again, if you click inside, you can scroll down to see that there's much more visible there than simply the output. So it shows us there's 10 rows there that are available. Okay, so that is a standard data set. Now, is there other useful stuff in there? Yes, there is. So if you go back and take the opportunity to actually just delete this COVID, okay, the last part of it, okay, which I'll do there just to show you. And I'll just do shift return again. It will execute that. And then again, you can see that it's taken us one level up. So there are other data sets inside there. And again, click inside the result and you scroll down and you see there's lots of stuff in there. Many other data sets, weather, Wikipedia, spam, let's see, what is it? Online retail, many other data sets that are available, okay? So I encourage you to spend a little bit of time in your own time, just explore those, take a look what's available, and you're welcome to utilize those. Okay, now, next thing here, Command 8. So what we'd like to do is take a look at this specific set of data that's available under that COVID directory. Okay, so if I just highlight this for you, okay, this is the full path now to what we're going to look at. COVID-19 daily reports. And again, we're doing a %fs.ls. Just show us what's actually in that location there. So if we do that, again, it shows us the contents of that. And we see here in the result output just below here, it says there's 417 rows have been returned. And if we, again, just click inside the result box and scroll down, we can see that these are all CSV files. So it looks like these are kind of, again, you know, as it says on the tin, daily reports for specific dates here. So I can see the 1st of January, 2021. I can see the 2nd of January, 2021, I think that is, and so on. And it looks to me that's the kind of the US format, the date format. So for us, perhaps a little bit confusing, but I mean, if you understand, they use the month first, followed by the day, followed by the year. So these are all CSV files there that contain these data sets, daily reports. Okay, so the last one that I can see in this list is 31st of December 2020. So fairly recent stuff, not a huge amount of data.
It
But
goes beyond that because I can see data from March 2021 in there as well as interspersed because it's alphabetically.
Yes, that's right. Yes. So you could, let's have a look. If we were to sort by path, for example, let's try that. And then what's the earliest one there? Oh, still. Oh, all right. Let me just have a look. Let's do by name. See what we can do there. Okay, there we are. So this one just does it in reverse order. What's the earliest one I can find? Yeah, I think you're right, Emo. So it's okay. No worries. Not important, but it's essentially we've got quite a lot of data in there. Lots of CSV files that we could, any one of them potentially you could use, but we're going to pick one in particular. And the one we're going to pick in particular, if you have a look at command 10, it is, let's have a look. It's this one here, okay, 04/11/2020.csv. Notice here at the beginning, it says a %fs head. So literally, we just want to look at the beginning of the file. We don't want to look at the entire contents. So this will give us the ability just to get the sense of what's actually in there. So again, just shift enter, execute the code. And here you can see some output. And again, inside, if you click on the box, you get to see. And one thing I notice is that we have a line. Looks like there's header information here, okay, which I'll kind of highlight here. There we go. That tells us what the column names are. So we've got things like FIPS, admin 2, province, state, country, region, last update, latitude, longitude, and so on. Confirmed, deaths, recovered, active, combined key, and so on. So there's quite a bit of information there. And immediately, the second line that I see there, it refers to a place called, I guess that's Abbeville, maybe, South Carolina. You may be seeing the same thing. Okay, so we've got some coordinates for that particular location. And which region is it in? Which it's the United States, province, state, South Carolina, and so on. Okay, so we've got quite a bit of information there. We've got some header information there as well inside this CSV file. So what we'd like to do is read this in, okay, and take a look at this in more detail. So the first thing we need to do is, in order to use the pandas, we've got to actually import this. And we use this kind of shortened name here. As you can see, import pandas as PD. This is command 12. Okay, just before we start using it. There we go. That's done. And then we're going to read that CSV file in. All right. Now, this is a kind of a multi-stage process. So have a look at the code in command 14. What's happening here? So we are telling Spark that there is a CSV file that we want to read. Okay. So that path is contained within that .csv that you can see there. Full path to the file. We are also telling Spark that there is a header. Okay, option, header is true. And we're also telling it this infer schema is true. So essentially what Spark will do is it will read that CSV file in. It knows that there is a header. We've just told it so it won't treat that as data. And we've asked it to figure out what is the structure. You know, what's the schema? What are the individual columns? Are they of type string, for example? Are they floating point, integer, whatever? You know, make a guess. Look at that file, evaluate it, and then sort of figure out what the individual columns should be. So this infer schema is very useful, great for small data sets, not recommended if you've got a file that's kind of a terabyte, 10 terabytes, or a petabyte in size, because Spark has to read the whole file. Right? It cannot simply sample it. That's not a good idea because we may have a mixture of column types in there. Like I said, one of the roles of the data scientist is to spend time cleaning up data So don't just assume that you've got a file that just because you sample it, the schema in the entire file may be the same. So in this case, it has to read the whole file in order to determine what the schema is and be able to arrive at a conclusion.
There's been a
So
couple of interesting questions on the chat. Would you like to have a look?
Yes. What are the? Oh, too many. There's 14. So I'm not sure.
Just the last two.
Last two. Do we import Spark already? Nope. Spark is already running. Okay, it's already running, and that is running on our cluster of one machine. And can we use PD read CSSE? You could do, Peter. Yes, that's right. That's possible. But I had some issues with that here. So you're welcome to try it out if you wish. But I wanted to do it this way because this way definitely works. Okay, so yes, you're absolutely right in observing that you can. There's an alternative way we could do this. So I'm kind of doing it in a two-step phase. So I'm going to read this into a Spark data frame and then convert that data frame to a Pandas data frame. That's the way I'm going to do it. This gives me a bit of confidence in the end result. So if we take a look at command 14, then, so the result of all this, reading that CSV file in, you can see we are assigning it to this variable called df. That is a data frame. So what is a data frame? Analogous to a spreadsheet or a relational table. You could think of it that way. Rows and columns. That's what it is. Okay. So if we do this, again, just execute this. There we go. You can see momentarily you saw Spark running and you got a little bit of information there just below. Okay. So it tells you that Spark ran. Okay. A couple of jobs ran. That's fine. I mean, we're not here to learn about Spark. We're just using it. But the more interesting thing is the data frame there just below. So if you expand that, you'll see that Spark has been able to infer the schema. It's picked out the fact that because we told it header is true, that it's correctly picked out the individual column names there. And to the best of its ability, then it's been able to analyze the individual rows for those particular columns and arrived at this particular schema. So you can see some of these columns are of type integer, some are of type string, some are of type double here, and that's absolutely fine. So we've got now values that we can actually look at and manipulate at and do some work with momentarily. Okay, and so here, because we're working with Pandas, so we're telling Spark here in command 15, take that data frame that you've just created, which is a Spark data frame, convert it to a Pandas data frame. Essentially, that's what's going on here. So if we execute this, it does that for us. There we go. And you see the output here, very similar to what we would see, okay, in terms of a Spark data frame. So again, we could see the output here. There's the column names across the top. And notice that the numbering in the left-hand column starts with 0. Okay, so the first row is numbered 0 there. So just keep that in mind. Okay, now at this point in time, you might be wondering, well, hang on a minute. We've just done this, but we haven't actually saved this anywhere. Absolutely correct. So we've told it to take the data frame that we've just created from Spark, convert that to Pandas, and it's very happily done that for us, but we haven't saved the result to anything. And so what we can do here in command 17 is essentially combine these couple of steps together to actually do all of that for us. And so here, if you take a look at command 17, well, I mean, strictly speaking, we don't need to repeat this, but it's just to show you that you don't necessarily have to write one cell with one line of code. Code can be combined, multiple steps can be combined. And so here you can see we're doing the import pandas as PD. We do that step of reading the CSV file into a Spark data frame. We convert that Spark data frame to a Pandas data frame, okay? And we're reusing the same variable, df, line 5 there of command 17. And then we just say df and it just shows us the output. So we should see if we do, I'm going to do shift return here on my Mac just to execute all that. There we go. And again, we see this output here. It's identical to what we just saw a moment ago. But now we have this, okay? this thing here. That's the key thing. Having this, now we can do something with this data. Okay. Okay, so what is the first thing we can do? Let's take a look what's actually in that data frame. Now, one of the things that one of the features that you have within this environment is this kind of tab completion, as it's called. And so have a look at command 20. You'll notice that it's commented out. It's kind of in green. So if you remove that first hash character, okay, and I'll just position my cursor here and hit the delete key. There we go. So I've now got df dot, and just after the dot, if I hit the tab key, okay, it says here loading. There we go. And it gives me some options here about what I might want to do. So this works in the two supported browsers for the Databricks environment, which is Chrome and Firefox. If you're using something else, it may work, it may not work, not guaranteed. But this could be useful. Again, save a little bit of time, could be helpful. So
it's working for me fine in Brave.
Sorry?
It works fine in Brave.
Okay, great, brilliant. The key thing to note is that Chrome and Firefox are 100% guaranteed to work absolutely with this environment. Anything else may work, may not work, just depends. All right, you're on your own there. Databricks can't guarantee that, you know, if you're doing that. All right, let me just comment that out, okay? Because I don't really need that. All right. How about we need some help? Well, here, command 22, df.head get help. I'm reminded of the, I was watching the Thor, you know, get help with Loki. Don't do get help. Just watching a little bit on video last night. But if we want to get any help, we can just pass, you know, what is the specific command that we're looking for, df.head, and just show us some help information on that. As you can see, it outputs quite a bit. Okay, this thing goes on. It's a bit like, you know, you're in a Linux or Unix environment, you do kind of man command, you'll get back lots of information and some examples and the various parameters and so on and how you use it. So this could be useful again. And again, it's because it's built into this environment, you don't have to go any, you know, externally to be able to find this information. So that could be helpful. Okay, so take that data frame here in command 24, just show us head. Okay, first couple of rows. So we saw the output a little bit earlier on, but there's a bit too much there. Here, by default, we get the first 5 rows. And again, you can pass a parameter to the head to say how many you want. So instead, I might say, just show me 3, for example. Put the parameter 3 in there, execute that. And there we go. I just get 3 rows there. Okay. So again, notice that the numbering that it's providing there starts from 0. I had something 2 weeks ago. I kind of forgot that. Just, I was trying to count the number of rows, and you know, I got to the bottom. There was an assumption that it should be a certain number of rows, and I was wondering why it was out a little bit, and I forgot that actually the numbering starts at 0. So well, that's okay. Similarly, we could look at the end of the data frame. Here we've got in command 25 tail, show us the last 2 rows that are currently in that data frame. There we go. And then here you can see that there's a couple of these cells seem to be missing some data. So we got this, or actually not a number as it says here, nan. All right. So again, part of the data scientist role, do some cleanup, look at some missing values, look at null values, find ways to fix all of that, or you know, substitute appropriate values there. Another thing you'll notice is that if you take a look at the head output and the tail output, notice that in the head output, for example, and I'm assuming you're seeing pretty much what I'm seeing, we've got country region, it says United States there. And we've got province state, you can see it's got this South Carolina, Louisiana, Virginia, and that's fine. And then in the tail, you see here, I've got Zimbabwe as the country region. Okay, no province state in that case. That's not been assigned. So we got a kind of a mixture in here, and we're going to filter some of this out. Okay, so we're going to look at some specific data shortly. Okay, one thing we might want to know is how big is this data frame? You know, show us how many rows are actually there. So this command 27 df.shape, take that data frame, tell us what you know about it in terms of rows and columns. Well, it's almost 3,000 rows and 12 columns. That's the value there. So 2967 by 12. Okay. And then here in command 28, you can see there's a bunch of these 6 rows. All of these are currently commented out. And on a Mac environment, and I'm not sure what it is on Windows, so I apologize. I can only say that, for example, if I position my cursor at the beginning of line 3 here in this command 29, and I hit command /, it removes the comment statement automatically for that. And if I do the same, it comments it again. So if I were to go to line 1 here, and let me just uncomment this, let me just do this df.sum command, and it provides some information here. Okay, some output. None seem to be particularly useful. I mean, I've got some deaths, confirmed, recovered, active, but there's an awful lot that, I mean, look at country region. I'm getting some very strange output here. So all this is US, US, US. It's maybe that's not particularly useful. So let's do that. And then we can have a look at minimum, for example. Let's take a look at that. Well, again, it's giving me some output here, but maybe this isn't a particularly good way to do this analysis. But essentially, you've got a range of these operations: min, max, count, mean, standard deviation. You might be interested in these, but there's a better way to do this. And you see that just below there in command 31, df.describe. So if you run this, essentially, it gives you lots of useful statistics there, like so, in a much more kind of digestible form. So for those various columns, okay, and by the way, in case you're wondering what FIPS stands for, it's this thing here. Let me show this to you. This is Federal Information Processing System codes for states and counties. All right. So this is just showing me at the level of individual states of the United States. Okay, they've got a state level FIP code, and then you've got these county level FIP codes as well. So this is a kind of a geographic location. This is because it's taken from this particular data set. That's what we're seeing there, in case you're kind of wondering, what does this really mean? But again, we've got, I mean, I guess what we're more interested in is in terms of confirmed cases, COVID, you know, number of deaths, how many recovered, how many currently active. That's the kind of thing that we might be much more interested in. Okay, and then we've got some statistics, as you can see: mean, minimum, 25% percentile, 50% percentile, 75% percentile. In the vast majority of cases, certainly for the active, recovered, and the deaths, those numbers don't seem to be very useful. And we got max as well there, as you can see. So, but the thing is that, you know, part of data analysis is discovery. Maybe you take the opportunity just to take a look at the data you have. Perhaps you discover some interesting things. Maybe you don't discover anything interesting. That's okay. You know, it's not time wasted. You will find things that might be helpful and other things that may be less helpful. So that's fine. Okay. So let's take the opportunity then to actually drill down and pick out just the confirmed cases from our data set. And so here you can see in command 34, we are just specifying the particular column that we're interested in. Okay, if we just execute this, confirmed cases, and so we get some data. As you can see, it's kind of summarized it here for us. So we get like the first 4 rows, and then we get the last 1, 2, 3, 4, 5. So it hasn't, there is a way that you can control all of this output if you want, but I mean, that would just go on screen. You'd be scrolling down a lot. So this as a summary is kind of helpful, but again, we'll take the opportunity to drill down a little bit more and take this, you know, get something more useful from this. Again, command 36 here. How many columns do we have? What are their names? As we can see, this pretty much matches what we saw earlier. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And one thing again that we can do then is look at the number of confirmed cases based on country region. So can you see what's happening here? That there is this ability to do this kind of slicing and dicing, pick out what you're interested in. You may find some interesting relationships. And so here, again, we get some output. Just shows us certainly the output that I've got at the country region level. Again, I'm just getting the first 5 rows. So those all happen to be in the United States. Confirmed cases, but as you can see, it doesn't give me any more detail at that level because I've just specifically picked those 2 columns. And then further down, I've got 1, 2, 3, 4, 5. And in that case, I've got West Bank and Gaza, Yemen, Zambia, Zimbabwe, and then you can see US pops in there again. So we need to do a bit more here to try to get some more meaningful information out of this. All right, so other things we can do, well, you know, being a data frame, and if you've worked with spreadsheets, you've worked with relational tables, much as we can do there, we can add new columns, we can do the same here, okay? So we can add a new column here, specifically a new column called date. And so here you can see in command 39, okay, specified that this is of this particular format. And we've got this specific date here that we're passing in. And let's take a look now at once we've added that to the data frame in command 40, do a head, which is a kind of quick way to have a look at this. And again, we can see indeed those values are there based upon that specific date that we've put in. All right, then. What else can we do? Well, let's just try to limit the number of rows that we've got. Okay, so previously we're kind of looking at all of it. So we get like the first 5 rows and it shows us the last 5 rows. But here in command 42, we have the ability to just control it a little bit and just get maybe 10 rows to take a look at that. And that's a bit more helpful. Now we're starting to see things that, you know, without that kind of pattern of just it picking up from the beginning and from the end. What else? Well, we can just return the first column from the first row. Okay, so you can see the coordinate 0, 0 there. And if you do this, you get this value 45001.0. Now, if you were sharp-eyed and you remember what we did a little bit earlier on, and let me just scroll up, okay, and go all the way back here, right to this thing here that we did. You'll notice here that in this data set, we have this first line, first row contains the column names, but the very first value just below is this one here, 45001. Okay, so that's what it's picking out there for us now. So this again, you know, gives you the ability to drill down, pick specific columns, pick specific values if you want them. Okay, now, so plenty of ways to look at the data, slice and dice, add new columns if we want to, pick out specific cells if we want to, again, just providing these kind of coordinates, as you can see here in command 44. And so let's take a look at a little bit more sort of useful analysis here. So here in Command 46, what we'll do is we'll take a look at this country regions, okay, and do this value counts. Let's take a look at this. So we can see here that at the level of country region, the biggest, the value that appears at the top, highest is the United States with 2,702. Next, we've got China, 33, Canada, 16, we got United Kingdom, 12, France, and so on. And then the last few there, you can see these last entries, they all come down to 1. So obviously there is some mechanism here that's being used in terms of dividing this up. So you saw for the United States how that was done. We looked at that data and we looked at the this kind of geographical way that it's being split up. So obviously the US is using some mechanism to at a very fine grain level, whereas some of these other countries seem to be much larger. So for China, I'm guessing it would be the names of these large kind of provinces. Canada, again, the same thing. I'm not sure how it's done at the level of United Kingdom. Maybe someone could help out there. But again, France, we can see we have these smaller numbers. Command 48, FIPS. I showed you that a few moments ago in terms of what that is. It may be something that is not very useful in our analysis, so we might want to drop that. So here you have the ability. So previously we added a column, now we're going to drop one. And obviously if we're going to drop one, we need to save that result back. So here you can see that we're saying in Command 48, take that data frame, drop that column, and then just assign that back to that same variable. And so if we do that, okay, and then we take a look at it again in Command 49, that will list us all the columns that it knows about. We can see indeed that FIPS one is now gone. It's disappeared, removed. Okay, other things we might want to do. Well, how about if we wanted to just take a look at the number of confirmed cases that we've got? Let's sort according to that. And we can do it in, it says here, ascending equals false. So what we'd like is the highest values to be at the top and the lowest values to be at the bottom. And if we do this, we can see certainly for this particular data set that we are looking at, and for the time that it's showing us, the first 5 rows there that I can see, the highest was for Spain. Confirmed cases, it's 163,027. Number of deaths is 16,606. How many recovered? 59,000. And how many were active? 87,312. And that was on that particular date, okay, that we've specified. Remember, we added that date column as well with that value, which is, again, that data set is for that date anyway, so it's kind of superfluous that we added. That wasn't really necessary, but it's okay. And the next one you can see in the list is Italy, and then Germany, and then there you can see this kind of odd thing. So we've got New York now appearing there. So for the others, for Spain, Italy, Germany, you see there's no province state being mentioned there. But for the United States, we see, yes, by country region, it's correct. But now we've got this individual kind of city appearing here, this kind of state, New York, where in the list, number of confirmed cases, number of deaths, we've got recovered, we've got active, 0 and 0. That looks a little bit suspicious. So I'm not sure if that's entirely accurate. We'll have a look at that in a sec. But then again, if we go right down, you can see that further down, for the last kind of 5 rows that are being output there, again, we've got these NaN values, not a number, okay? And we've got things that are unassigned here. So obviously there's some work that would need to be done here to do a bit of cleanup there, okay? So, and again, we can see here, all of these come down to 0. So doing it in this kind of reverse order is better, because then we get to see the highest values at the top. Otherwise, it would give us the uninteresting data first. All right, then. So far, we've kind of looked at the data globally. how about if we just focus on the United States then, right? So we can do that very simply here. So just take the data frame, focus in on where the country region is just United States. That's what we want to take a look at. Okay, and here we can do this. So now we are just looking, and if we look at the province state, we are actually getting these correct values: South Carolina, Virginia, Idaho, Iowa, Louisiana, and so on. And again, it seems to have done them well. We've got this very first one is actually the first row that we have in our data set. If you are, again, sharp-eyed, you remember this from earlier, Abbeville, I'm guessing, South Carolina. Okay, so we've got that back. And then again, we've got a lot of fine control that we can specify in terms of, slicing and dicing a little bit more. So here it says this in my county. Well, I don't live there, okay? But here you can see that we are saying, okay, country region is US, as above. Then let's drill down to specific province state, California. And what we're interested in is this admin 2, which I guess is down to the city level, which is San Francisco, okay? So we're looking at San Francisco and California in the United States. So you can see that through this process of just saying, okay, we want this, and then we want this, and then we want this, we can easily do that. Just pick out exactly what we're interested in. And here we get back the row for San Francisco. And let's take a look at this particular point. We had the confirmed cases at 857, number of deaths 13, 0 recovered, 0 active. And again, that date column is got exactly that same value that is based on this particular CSV file. And as I said before, we added this extra column. It doesn't really serve a lot of purpose, but the goal was to just show you that we could do this, okay? Okay, then what else? What might we be interested in? Well, which country has the greatest number of confirmed cases? We can do a group by. This is command 58. Okay, run this. And now what we can do is we can take this and then specifically look at using this sum and then sort. So can you see the flexibility that you get here is it's kind of step by step. So we're saying we want to do this. Okay, we want to do a group by on this. Look at the number of confirmed cases, sum them, now sort them. Okay, so it's like a kind of a pipeline that we're creating. We're able to add these extra sort of steps on finally to get exactly what we want. And if we do this, we can see that in this particular data set, at that particular sort of whatever snapshot in time that this represents, the United States, what's that? 1, 2, 3, it says 526,764. That's the top of the list. Spain was second, Italy, then Germany, then France. And then those that are appearing right at the bottom of the list, Samoa, Yemen, Timor-Leste, Papua New Guinea, South Sudan, very low cases. So for this particular snapshot, that particular point in time, I mean, this is the number of COVID confirmed cases that we have for these specific countries. Okay, now, given our focus on the United States specifically, we might say, well, okay, let's take a look at of the states of the United States and perhaps some other, there's things like Guam, for example, which I think is not counted as a state, and maybe some other things that I added on. So I think the number may be slightly bigger. We can again say here, command 62, what we're interested in the United States. Let's group by the province, look at confirmed cases, sum them, and again, sort them. So again, we're building that pipeline, just specifying exactly what we want. And once we've done this, here you can see far and away, the most are in New York, which I think, again, at the time that this particular data set represents, this report is probably true, followed by New Jersey, and then we've got Michigan, Massachusetts, and so on. And these are all then, let's find what's the lowest one. What do we got? North Mariana Islands. Okay. There's an interesting one. Diamond Princess. That's Virginia Islands. Okay. Grand Princess. Okay. Guam.
Those were cruise liners, weren't they?
Yeah, that's right. So there you go. So for this particular data set, that's where they're appearing. I was wondering why you would get these cruise lines. But again, if you look at the rest of those, so it's not simply the states themselves, but there's other things that have been added here. So just quick scan of these states, the list looks complete as far as I can see. And then we've got a Puerto Rico, for example, that's there, Guam, and the Virgin Islands. Obviously, they are not a state of the United States, but nevertheless, the United States is responsible for those. And so I think overall, if I look at the Alaska seems to have the lowest number there as far as the proper states, the United States are concerned, 257 for that one. Okay, now you've seen some examples. Okay, so we're almost done. Okay, just a couple more minutes and we're finished. Well, part of the analysis process has revealed that there seem to be some kind of missing bits of data. Not a number, or simply the column says that there's nothing there. We can test. There's a couple of useful commands that allow us this ability to look at, see, here in command 65, for example, show us the null, df dot is null. How many of them can you see? Just to show us these things here. So if I look at this, I can see that there are some cases here. You can see where we've got these, I guess, false. Yeah, there's a lot of stuff here that, well, here, and just give us a summary, show us how many of these are actually.
Does that mean that that particular row of the data frame contains a null at that point? Is that the Boolean value?
Yes, this is false.
False means it's not null.
No, but it's marking, and this is how it's reading it. So I know true and false. Null is not zero. It's not blank. It's not empty. But here, this is picking it up as a value that's not there. Okay. So
that sounds like a fairly unhelpful way of doing that. Then surely there could be loads of tables where we just see falses, and we're going to pick those up.
Oh yes, yes.
Okay.
You can control this, by the way.
Okay.
Okay.
Yeah,
so I'm simply we haven't. I mean, we're essentially taking the defaults. Well,
yeah, that's fine.
This gives you a lot of control. Okay, that's essentially what I'm trying to say. And then here, if we just take a sort of summary of show us the actual values that we've got, so you can see that across the different columns here, we can see this admin 2 has got 272, province state 181, country region 0, latitude, longitude seem to be some things that are missing there. So that could be useful. But yes, I agree. So that null is, certainly in my background in database systems, it's not zero, it's not a blank, it's not true, it's not false, it's something else. It's just a way of representing something that's missing. So here you can see that, there is output that's coming out here, which on the face of it, yes, it doesn't look like it's giving us the correct way to represent this, but one of the things that you can do within this environment, obviously there's a lot of fine control, which again, unfortunately, because of time, we're not able to cover. Okay, all right, we're almost there, almost at the end. Just show us how many unique countries have we got? Okay, so this is 68, 185 country region. Okay, and another way to do this is just to say drop duplicates. Okay, so
is shape there showing us the shape of the frame? So that's 185.
Yeah.
And does the missing second piece there mean that it's got varying size in the other dimension? Or does it mean something else?
In this case, it's just one. We've simply asking for the country region. Okay, that's the only column we're interested in. Right. Yeah. Okay, so if we do that, as you can see, the output here just shows us here in command 70 that again, US, then we got Canada, United Kingdom, China, Netherlands. So this is just listing out all of these things. Now, again, where does this 185 rows comes from? Well, part of that is because, remember, the US uses a slightly different way to represent this, and this is why the number is somewhat larger. One good way that we would do as perhaps data analyst is to say, well, okay, let's mark anything that's not, this fill NA where the data are not actually available. Actually give us the ability to do that, and we can do that here. Okay, so this is slightly better than I think using the previous way. So you can see in this case, we see that some instances here, no data available, okay, which is probably better. All right, so again, here you've got this thing called unassigned as well, for example. But I think the key point here is that, data, if you get a perfect data set, well done, congratulations, you're lucky. Chances are that's not going to be true. So just part of this process, and I hope that's been helpful, is that, don't be afraid, look at the data, slice and dice, look for certain patterns, look for certain values, investigate. And once you have a good understanding of what the data look like, you may be able to say, well, okay, it needs some additional processing. We need to be able to take care of things like missing data, or we need to, create values, however you want to do that, that might represent what the missing data should be. And this could be based upon values above and below, or to the side, or whatever, or take some kind of average or something like that. Oh, you might remove the row altogether. That's entirely possible. There's a range of things that you could do. And it's part of that process of just using a lot of these simple commands just to get an idea of what the data actually look like. That I think that's the key lesson here. Quickly, just a couple of visualizations then, and then we're done. So here, just to show you a histogram and scatter plots. So this is Matplotlib. Pretty standard stuff here. And here in command 74, we're just going to take country, region, United States, which we did a little bit earlier. Remember, we were just interested in that. And we just assigned this to this variable, US subset DF. So that now is saving that so we can do some additional processing on it. And so here in command 76, can you see, again, what we're doing? We can chain these commands together. So we're telling it, do a group by, okay, based on province state, the number of deaths is what we're interested in, sum those, and then create a histogram from that. So there we go. And if we do that, you can see that based upon this, most of this seems to appear out on this side here, okay? Certainly the number of deaths seem to be fairly low. A couple of outliers, we've got this one here, right on the end. You can probably guess what that one is. And then again, we've got a little bit here. So there's certainly a few cases there. We can refine this slightly. So here in the next command, where are we? 77. Notice that we can provide some parameters to this histogram. Bins equals 30. Feel free to change that to whatever value you want. 30 is a good one just to get an initial sense, but you could try 60, for example, or 100 to give you a bit more detail here. And if we do, we get a bit more detail, as you can see. So certainly we can drill down a bit further. So again, we can see the vast majority of deaths seem to be at this end. The most of these states of the United States tend to have fairly low, and then there's a couple of, again, we can see there's a couple of outliers here, a few things that are a little bit further along, and we got this one right on the end, which seems to probably needs some further investigation. And then finally, let's find out what that actually is. So here we can do a scatter plot. So there is a slightly different way to represent this. And by the way, if you haven't guessed, this is New York. Okay, so this at that particular time was quite a significant problem for the New York City. And if we remove that, here we can do that in Command 80, for example. Very simple to do is simply providing this parameter saying, okay, if the number of deaths is less than 1,000, essentially that just removes it. I mean, it's just a super simple way of eliminating that one outlier. And then otherwise do exactly the same, plot the same thing here. And if you do that again, this, there we go. Slightly better representation there. You can see, okay, removing that single outlier. Okay, so apologies, I'm a little bit over. Sorry about that. It did take us a bit of time to get set up initially, but as you can see, so this environment is, I think, very useful for learning. If you've worked with notebooks, Jupyter notebooks, then certainly this should be something quite familiar to you. Pandas is great for the type of problems where you're essentially working on a single node, which we are within this community edition environment. However, if you want to scale up to much larger data sets and you want to work with proper cluster computing, and what proper, by that I mean, where you've got, say, a driver and multiple workers, a cluster of actual machines that divide and conquer. Okay, you're allocating the work to each of these machines. They do some small part of that. Then you want to use a Databricks cluster on one of the cloud platforms in order to give you that capability. And in that case, there is a technology that you might want to look at. It's called koalas. Okay. GitHub, Pandas. Okay, let me just do that for you. There we are. So this is effectively giving you the equivalent of Pandas, but the ability to run this on a cluster of machines rather than a single machine. Okay, so this is a project that's actually on GitHub through Databricks. So again, this is open source, free to download, free to try out. But obviously, in order to make use of this, you will need a proper cluster, not just a single driver in order to utilize this. So that could be useful in that scenario. So for those of you that attended 2 weeks ago, again, you remember that we were using scikit-learn, and scikit-learn, again, great for single node. But if you want to scale out, then essentially, let's say you've got a big machine learning problem and lots of data you want to analyze, then using this CE environment is probably not the best thing to do. And you might want to think about, looking at some of the enterprise options. But again, that's something to think about, depending on if it's a customer case study or problem, then I'm sure you'll consider that. But this could be something to think about. So koalas as a way to effectively use pandas, but in a distributed computing environment. So this will work a lot better. Okay, great. So I apologize. 18 questions there. I'm sorry, wasn't able to keep up with this, and it's so let me see anything else that I can add. Right. So Ricky, you're asking about Spark RDDs. Well, keep in mind that RDDs are not really recommended now. So essentially, data frames is the way to go. Years back in the early days of Spark, RDDs was what you tended to work with. That was the way to distribute data and to work with data. But think of RDDs as the assembly language of Spark now. So really, you work with higher level APIs, data frame API, PySpark, for example, or you could work through Scala or SQL if you want, though that would be much better. Here, the reason I'm using Pandas is because I'm limited by the fact that it's community edition. Okay, so I thought that would be fine. That's the only reason there. Dave, right. So yes, so the thing, your question about CSV files. So I think my point there is, what I would say is that in enterprise environments, relational databases, although they are the dominant database technology today, nevertheless, huge quantities of data are still stored in files, spreadsheets, lots of other formats. And so sometimes as a data scientist, you may receive data in one of those formats. So you will then have to do some exploratory analysis. You've got to read it in to some kind of technology. In this case, Pandas was one example. Equally, there are other tools out there that you could use. And so what we're trying to show here is the ease with which you can read something like a CSV file in, just do some initial analysis, look at the rows, look at the columns, slice and dice, just do a bit of manipulation and maybe some visualization just to get a sense of what the data are telling you. And so that was the main thing here. Of course, really, there will be a wide range of data sources you might work with, relational databases being one of them, of course. Equally, you might be streaming data into your system. That might be a source, say for IoT data, wearables, sensors, this kind of thing. That might be another way that you get data into your system as well. Okay, so there's loads of different formats, as you know, for handling files and data. And we just happen to use one particular one today. I'm not saying it's particularly preferred over any other. It's just simply that the data sets that we were looking at were just in a CSV format. Steve, you got some points there today. Splunk, I apologize. I'm not familiar. I've heard of the vendor. I maybe have come across them from time to time, but I'm not familiar with their tool set or their technology.
I'll tell you something about Splunk. It's essentially, it was designed as a way of slurping up masses of log data from running system and then doing some analysis on that.
Okay.
And, a lot of the stuff that you've seen today is paralleled in Splunk, but it's a completely parallel implementation, and it's highly expensive as well.
Yes. Okay, gotcha. Yes, so I think certainly with the Pandas, you can see it's very much, how to say, there's not an awful lot of automation here. So for example, I can't just ingest the data in and then ask the system, go away and just tell me what you've found, what you've discovered. You can see it's very much driven by the individual. We've had to do stuff. We've had to run code. We've decided which particular commands we want, how to do the exploratory analysis, how to do the visualizations, all of this. And so I think, again, although there's a lot of automation that's appearing, there's many tools that are appearing on the market, for example, and I think I mentioned this 2 weeks ago, that, and I think, Imo, you raised this issue as well about, how to choose the correct model, for example, when you're doing machine learning or data science. Difficult task, sometimes you may choose one for your initial analysis. It might not be the right one, then go away and choose another one. That might be better. There are tools out there that will now allow you to do this. They'll look at many different models, look at hundreds of parameters, change things, tweak things, and they can automate this task. They do it a lot faster than humans can do it, and that's great, okay? And they'll come up with some conclusions and recommendations based upon, whatever criteria you specify is what you're looking for as the best, in quotes, solution. It might be that that's the way to do it. Raymond, you're asking about data cleaning? Definitely. So like I said before, often if you're taking many of these MOOCs, these types of courses, they will give you the very clean data set. It's perfect, right? In reality, that's going to be rare, I would say. I mean, certainly from what I've seen. I mean, I'm by no means am I a data scientist, but nevertheless, I do deal with some data. And what I see is there are lots of imperfections. Missing values, null values, corrupt values. So doing a lot of cleaning analysis is important. Figuring out how to deal with missing values, that's also very important. That could have an impact on your overall results. should you remove those rows? Should you fill them in somehow? There's a whole range of decisions that you have to take based upon that. All right, let me just have a look. Right, so yes, Dave, you've got a couple of observations there in terms of the regions, maybe. Yeah, EU L3 regions could be indeed. Unfortunately, I don't know enough about that, but NHS, that sounds about right. I would guess that's the reason we had those.
While you mention my name, I've got an actual question though, rather than that one. There was a couple of idiosyncrasies in the way the data came out. So there was a couple of some line breaks and stuff that looked a bit weird. But there was one where we kind of saw some recovered lines cropping up at the end of some stuff. I'm guessing that was just an artifact of the weirdness in the data rather than an artifact of how Pandas or
yes,
okay,
yes,
that's fine. Yeah, okay.
That's right. So that's a great observation. So again, we took the CSV file, but we didn't perform any cleanup or prep work on that before we started using it. So what we were doing is essentially part of that analysis. We were looking at the data, trying to see, is there stuff there that looks a bit suspicious? Is there stuff there that is not quite right? Can we identify anything that might be a cause for concern for us? So again, it's that kind of phase that we go through to look at that data, come to some conclusions about it, and then decide what steps we're going to take to improve the quality of that, perhaps take some action, see if we can't find ways to fill in the missing data or remove some of the values that might be suspicious. But again, that has an impact upon the results that we might have. But again, don't make an assumption that just because you're getting a CSV file, the data are perfect, right?
Yeah.
So that's the key point. Hence the reason why we did the stuff we did. Okay, so it's to get you guys thinking about these problems. So it's by no means a perfect data set. So that's the main thing there. Okay, great. All right, well, great. I think we're over time, so my apologies for that. So again, my sincere thanks to everyone for sticking through and working through that. So I hope it's been useful. Like I said, I'm no data scientist. I'm not, by all means, reach out to me if you have some questions. You're very welcome to do that. But I hope what this has shown you is that there are some good technologies out there, that this was very much a hands-on approach. You had the opportunity to code along with me and to look at the data. Now, as a next step, what you might want to do is go away and do a bit of exploratory analysis yourself. So go and change some of the parameters. Take a look at some of these commands, see what options you have available. There is a lot of fine-grained control that you can have over these commands, much more that you can do than we've had time to go through here. And I think Dave, for example, and you highlighted the fact that handling the is null is not, it doesn't seem to be a particularly good way to do it. Well, there's some options that you can specify to give you greater control over that, right? So that's the key thing. Pandas is extremely powerful for data analysis. It's widely used. Data scientists use it all the time. And so again, our choice of using that was really driven by the fact that this community edition that we have, we only get one machine. That's really it. So trying to use anything else on that, if we had a proper cluster of several workers and a driver, then it would make sense to perhaps look at something else instead. But given the constraint that we have within the CE environment, then we are really a little bit limited in terms of the tools that we can use effectively, if I can put it that way. So by all means, take a look at the other data sets that are available there as well, and feel free to spend time, adding, removing, do what you like, be as destructive as you want. Remember the data sets as you read them in. So the Databricks -datasets is a read-only. So certainly you'll be able to grab the data sets from there, load them into your local environment, and then you can do what you want with them. Okay, you can delete, add, whatever you like. It's fine. There are other mechanisms as well. So for example, you want to save your results out. So none of the stuff we did there actually saved any of the results out anyway, other than the visualizations, which we did. But if you want to save the data out, there are commands to be able to do that. For example, you might, after doing some analysis, say, well, okay, now I want to save this out to a file so that I can then use this as inputs to some other tool that I want to use. And that's perfectly possible. So lots of possibilities there. And really, it's just scratching the surface. We've just been able to do a little bit today. Hopefully it's been useful for you, just to give you a little bit of hands-on experience and get thinking about this. And so if this is totally new to you, well, this could be your first step into data science. And that could be a great way to start. I think some of you have observed, there are commercial tools out there as well that can do a lot of this. Could be quite expensive. A lot of this open source technology is awesome, but you do need to put a bit of effort in yourself. I think that's the key point I'm trying to make. No, don't just assume that you get all this stuff for free and you don't have to put any effort in, okay? So that's the main thing. So again, thank you all very much for your time, for your patience. Reach out to me. I'm on LinkedIn if you want to connect with me. And again, I hope Emo will invite me back in the near future. And like I said, 20 years since I think I did the first one for the OOPS specialist group. I have a feeling actually I did one earlier than that, but I can't remember the exact date for that. So we'll see. So over to you, Emo. Thank you very much, sir.
Well, thanks very much. We don't have to finish hard on 8 o'clock. Okay. Normally we're allowed till 8:15 or so.
Okay, that's great. I'm happy to stay on. So if there are any further questions, I mean, maybe you'd like to. I mean, if there's anything that you've picked up in the discussions, I see lots of questions there, but I'm not. I scroll back to them, so I'm not quite sure which ones I should answer. So if there's anything in particular that's caught your eye, let me know, okay? And I'll do my best to answer
question for you, because I attended the Minispa event a couple of weeks ago, which you also very kindly did. And you took us through a similar exercise with Scikit.
Yeah, Scikit-learn, yes.
Yes. Now, I got the feeling that you're actually getting results more quickly with that one. And I mean, you got as far as curve fitting in about the same time.
Yeah.
What's your feeling? Which of the tools is the more productive to use?
Yeah, so I think Scikit-learn is also great. I mean, for people who have good Python skills, that over time, Python has, I mean, it's been, as a language, it's been around for quite a while, surprisingly. I mean, I only was introduced to it a few years ago, but I was surprised to learn how mature and it's the time of its birth. It's been around for quite a long time. But over the past couple of years, especially with a lot of the libraries that have been built around it, it has become an extremely powerful tool for data scientists now. And I've had the opportunity to use R as well, which I think personally is awesome. It's like SQL. It reminds me very much of the power that you get with SQL. A couple of lines of SQL can do an awful lot. Well, it's the same with R. But Python is proving very popular, and there are lots of libraries available. So the Scikit-learn is one of these that you're absolutely right. There's a lot of capability that's built in. It's reasonably easy to use, in my opinion. And again, what we saw, the ability to slice and dice, being able to do the visualizations, there's a lot of analysis that can be performed quite quickly. I think I have no particular preference. My feeling is that it's like a toolbox that you have. You've got a whole bunch of these technologies available, Scikit-learn, Pandas, amongst many. And it will be a skilled data scientist will be able to pick the right tool for the job, and they'll be able to based on the kind of analysis they want to do, what particular insights they're looking for, how much cleanup they need to do. It's a question of just finding the appropriate tool, utilizing that, and then performing what is usually 80% of the time, which is pretty boring stuff. And so model building is the next bit. And then the exciting part is the last kind of couple of percent, I think, typically. But personally, I have no preference. I think all of these tools are good in their own way. And it's just a question of what you want to use. Some people have some personal preferences. Like I said, I'm not a data scientist. I'm happy to use any of them. And okay, so I think it's just a question of where does the tool fit, and how useful is it for the problem that you're trying to look at.
Okay, I've been writing quite a bit of Python just recently, and one of the useful things about it is that you've got a unit testing framework, or in fact, you've got lots of unit testing frameworks to choose from. I don't know whether scikit-learn has anything equivalent.
Not that I'm aware of, but I can check for you. Maybe someone else on the meeting might be able to post some comments in Zoom. Offhand, I'm not aware of it. I've used scikit-learn a little bit, not extensively. So I was introduced to it a couple of years ago when I was looking at doing some analysis of, and this is the kind of standard problem that everyone ends up looking at, and it's the Titanic data set, okay? So you're looking at how many people survived, how many people died, and then you're trying to do an analysis based upon who survived, you know, which class were they traveling in, were they male, were they female, were they children, all of that kind of thing. And so that's when I first came across it, and it was surprising to me how, you know, powerful the analysis could be. Again, in terms of a few lines of code, gave me the ability to get good insights fairly quickly. So that was my introduction to scikit-learn from a couple of years ago. But that's really been at about the level that I've worked with it. Nothing really deeper than that, and nothing, you know, significantly larger in terms of data science type problems.
Yeah, I guess with these notebooks, you're just developing a pipeline, if you like, of data processing steps.
Yeah.
And the need for unit testing is really minimized because you
Whoa! So I was going to jump in politely there, but now I'm going to jump in impolitely. No, I'm going to very politely disagree with you though. I think the need for unit testing, the need for testing, this is going to be my question, in fact. So I've just jumped in a little bit early. It is changed massively when you're doing this kind of thing, but it doesn't vanish. In fact, I think it gets more key. In fact, my question was going to be something like, well, what do you do next? Because we've seen renewed attention to reproducibility, especially reproducibility in science generally over the past couple of years. And what this gives us is a really powerful tool. And I think it was Bjarne Strustrup that said, when you go from C to C++, the chance of shooting yourself in the foot doesn't get any bigger, but when you shoot yourself in the foot, you blow your whole leg off.
Yeah.
What this gives us is some renewed power for doing science more rapidly, but perhaps more informally. And I think one of the dangers there is that we don't do it properly. So I think, so Immo, in fact, both of you, I was going to say, when we talk about unit testing here, how do we do that when we're looking at science, where we're not looking at just saying, does my Python work? We're saying, does it give me the right answers? And that's a very different question when we look at this kind of thing than it is when you're saying, well, you know, the user presses a button and now we flip a database, which is it's not that, it's something very much more complex. How do we do that?
Yeah, so I think for this environment, you're absolutely right, Dave. So you can see it's almost like that concept of citizen data scientist. You know, anyone can do this stuff now. And the other thing is it's interactive, it's kind of iterative. So you try something out, you look at the results, maybe it's not what you expected, you go back, change something, rerun it, and you can keep doing that. And so that there's plenty of flexibility here in terms of executing the code and re-executing the code. I absolutely agree with your comments about reproducibility. Having been a researcher a long time ago in academia, and one of the things that is very important in terms of publishing your results is that you can provide enough information for somebody else to take that and be able to reproduce your results and get the same kind of answers that you were able to do. And that's part of you know, the peer, if you like, review of work and what we add to the body of human knowledge. In this kind of environment, you see it's very interactive, very iterative. There isn't much control in terms of what you can do. So someone can't stop you and say, okay, don't do this or don't do that. It's very exploratory in nature and very iterative in nature as well. So none of those unit tests you can see are kind of built into this environment. How you would do them, that's a great question. I'll have to look into that and see what my colleagues do on kind of production environments.
So if we have time, and if no one else has a question, I'll have a follow-up, but I'll happily follow up with you elsewhere if other people have questions, or if we just need to, drop.
Yep.
Everyone's being quiet. I'm going to squeeze one in. I guess
yes.
I won't seek an answer now, but my next question was going to be, and I will try and follow up with you after. So we do this iterative kind of rapid development of interactive examination of these things. Then what? So what I didn't get from today was, well, we've done these 30 odd steps that we've run inside Databricks using Pandas. Can we then deploy that in some way that lets us do this more? Is it entirely interactive, or is the interactive part a development of the thing that we then deploy in a different way?
Right, so that's a great question. So typically for these notebooks, it is very much the case that the notebook is the kind of the standard unit of development. However, not all organizations choose to do that. So there is a way that you can connect to your cluster using your favorite IDE, for example. And so you can write code, and that code could be packaged up, for example, and it might be for some particular analysis that you're doing. Equally, there are libraries that you can build, again, as jar files, for example, that may contain some functionality or some analysis that you want to perform, and you can attach them to a cluster and allow you to do that. Within the CE environment, we're a bit limited in that, unfortunately, but generally, yes, in enterprise environments, there's much more that you would tend to do. So Databricks, and again, I didn't want to mention too much commercial stuff, but all I would say is they have this technology, it's MLib, okay, machine learning library, which is available, and there's a technology called MLflow, which essentially handles this whole life cycle of machine learning end to end. And there are various like a tracking server, okay, a model server. There's a whole range of things that you can use to save your artifacts as part of some experiments that you've done. And that whole issue of reproducibility comes into this as well, because it allows you to have an experiment, multiple runs, save all the results of that, and then you can specify, okay, well, I don't necessarily want to rerun this in this environment. I want another target environment that I'd like to run it in. And you can do that. It can save all the information to allow you to do this. That's perfectly possible.
Thank you.
And one of the comments I saw there from Raymond there, the hypothesis testing is radically different from features testing. Yes, absolutely. So, there is, I think, the whole aspect to machine learning, data science, we are, it's like the null hypothesis and so on. You are testing some aspects of this. There's feature engineering, all sorts of things that can be done. And I think, like I said, for the data scientist, I think this environment can be very, very useful, very productive, very insightful, can get analysis and insights into the data quite quickly. And especially for anyone that's kind of familiar with the technology. So someone who knows scikit-learn, for example, someone who's familiar with Pandas, certainly for this environment, as you can see, doesn't require a lot of effort to get up and running. And, it's very kind of iterative as well, can do the exploratory analysis quickly, can look at the data, and then make some assumptions or make some conclusions based upon what's observed there. So.
And apologies, both, if I can jump in on that one. I think Raymond's point, the hypothesis testing is different from feature testing. I think there are actually at least three different kinds of testing there. So if you've written some Python, you can do the standard Python to test that Python does what you think it does. And then there's a different kind of Python testing that says, well, actually, I'm not just going to measure some simple coverage metrics to make sure my stuff is done. I need to do different because this is now in a massively different domain. And then you get to testing your actual hypothesis using the software that you've just written. So there's at least three things, maybe more, at least three different kinds of testing, maybe more. Sorry.
Useful observation. Maybe we should conclude on that, as we've now really run out of time. So this recording will be available within a few days on the BCS SPA playlist on YouTube, which is linked from the bcsspa.org website. Thanks again, Akmal. Fantastic talk. And everybody who's still here, please don't forget to come back in 4 weeks' time to hear Neda Talay speaking on Scaled Agile Framework, and tell your friends. Thanks, everyone.
Thank you very much.
Thank you, everyone.